Today's modern Borewell machines drill with high-pressure air, which can drill up to a depth of 2,500 meters, which is approximately 2.5 kilometers. The air pressure of its compressor will amaze you with its 4,500 psi. Can you imagine how much this is? You can guess from the fact that the tires of our vehicles are filled with air at a pressure of only 30 to 40 psi. The machine you are seeing is called down-the-hole drilling rig, which is called DTH in short. This Borewell machine works just like the small drill machine in our house. But the drill bit used here is of a different type, which operates on high-pressure air, which is a very brilliant piece of engineering. This machine basically has two separate mechanisms which work together, one in the compressor, which works to compress air at high pressure, and the other mechanism is the drilling rig, which works to drill the borewell. Sometimes, you will see the compressor and drill rig on the same truck, but the size of the compressor of heavy-duty machines is very large, so their compressor is kept on a separate truck. Actually, most of the time, we are interested in seeing this drilling rig, but here the mastermind is the compressor, which is loaded on the side truck. Here a heavy-duty engine is installed, which has a power of about 400 to 500 HP. It depends on the drilling power of the machine. If the machine can drill up to 1,000 meters, then the power of the engine will also be less. This engine can be of 12 cylinders, which works just like the engine of our normal vehicles. The compressor is attached to the main shaft of the engine. It is a rotary screw-type compressor. This compressor has two rotors, one male rotor and the other female rotor. Only the male rotor gets direct power from the engine. There is an air filter before the compressor, which pulls the air from outside inward and removes the dust particles available in the air. Later, the air reaches near these rotors, and these rotors are made in such a way that once the air gets trapped, it is not allowed to go back and will be compressed in a small area in the front, and by the time it reaches here, the air pressure will increase a lot, but at the same time, the temperature of the air also increases a lot. So we need to cool it a little. So there are powerful radiators here which work to cool down this high-pressure air. After reducing the temperature of the air, with the help of flexible pipe, the air is sent to the control board of the drilling rig. The pressure is managed from this control board, and from here the high-pressure air goes to the swivel mechanism. Swivel is a very important component which connects the high-pressure air to the drill string, and from here onwards the drilling starts. But it is important to understand this mechanism a little. Here there are two air motors on the side which work to rotate this entire string. But drilling does not happen with this rotation. It has some different work. I'll tell you about it later. These two motors also work with air pressure, whose mechanism we should understand. The rotor of the motor is not in the center, but a little offset from the center. When high-pressure air comes here, force is applied on these blades, due to which the rotor starts rotating. When it reaches here, applying force on the air blade, the area becomes very large, due to which the air pressure goes down, and this low pressure of air is of no use to us. So here, the air is released from the hull on the side. In this way, the motor starts rotating continuously. This motor looks small, but its power is very high. The main pipe is directly connected to the pipes of these strings from the control board, in which extremely high pressure is sent. That is why these pipes are made of strong steel. A drill bit is attached in front of these pipes, which is actually a hammer, and this hammer can break away strong stone, which is a great engineering. Although this entire hammer is made of high-strength steel, but only its front part comes in direct contact with the stone, on which some such balls are attached, and these balls are very long, which are fitted properly in the hammer head. This ball is made of a very strong metal called tungsten carbide, due to which this ball gives a powerful stroke. They can bear a lot of load, and friction also does not make much difference to them. Let us open the hammer and see what process is going on inside. This is the main hammer. There is a ball in front of it. There is a heavy piston behind the hammer, which continuously strikes the hammer, and an empty cylinder is attached on top of the piston. Look, you may get confused here, so try to understand it properly. There are two chambers above and below the piston, and we know very well that if there is high pressure on one side of the piston and low pressure on the other side, Then the piston will go from high pressure to low pressure side. For now, look at the chamber below the piston. It is completely empty. Now, first of all, high pressure will come from the compressor. The check wall will open, and from here, high pressure will go near the air distributor. The air distributor will spread the air all around. Now, the air comes out from the holes made on the top side of the cylinder, and the air will enter the cylinder from the lower hull through this cylinder. Now, from inside this cylinder, the air will either go up or down because the cylinder will not let the air go from outside. It is blocked from here. Now the air wants to go out, but the piston has blocked the air from here as well. So then the air starts going up from this cylinder. Look here. The chambers remain. So for now, the air will start filling up the piston through these chambers, and it will apply force on the piston from top to bottom. Now there is high pressure on the top of the piston and low pressure on the bottom. So the piston will come down at speed and strike the hammer. As soon as the hammer strikes, whatever air is in the upper chamber of the piston will come out from under the hammer through a hole inside the piston. Now the upper chamber is empty, which means the piston can come back up. Now this gap in the chamber below the piston will start filling with air downwards, due to which the piston will start rising up again. And when the piston comes to this position, all the air that was in the chamber below the piston will be completely taken out from inside the hammer. And again, the air will start filling back in the upper chamber, and again, the piston will go and strike the hammer. So this process continues automatically, and this work is so fast that this piston strikes 1,500 to 2,500 times in 1 minute, which is called blows per minute. And when this machine runs, you'll hear the sound of a bell ringing immediately. At high speed, actually, that sound is of this hammer. Now, when the hammer strikes the stone at such a high speed, the stone starts getting cut very finely. But it is necessary to bring out this waste of the stone. Otherwise, the hammer will get stuck. So the air pressure that comes out after striking the hammer is very high. So it brings up with it stone pieces, mud, water, whatever it gets. When the Borewell is completely drilled, the bore needs to be cleaned. And in this condition, the hammer is stopped. And the hammer will pass all the air from the side, whose pressure is very high. And this air brings everything with it while coming up. Now here comes the biggest challenge. This hammer has a lot of power. It can break any stone, but sometimes the stone is so strong that the hammer is striking it regularly, but the pipes installed above it are not able to pull weight on the hammer, due to which the stone does not break. So then this tower has a hydraulic pressure pump installed at the back, and this pump is connected to this pulley. It is connected to the mechanism, and this pulley is connected to the rotating swivel, due to which the direct pressure of the pump is applied on these pipes through the swivel, and the pressure of these pipes is applied on the hammer. So whenever a strong stone comes, then actually this hydraulic pressure exerts more force on the hammer to break the stone. And actually, if I tell you this hydraulic pressure is applied to move the swivel mechanism up and down in today's modern DTH. There's no old rope and pulley system inside these machines to move the swivel up and down or to take these pipes out, because here there is a very heavy load of these pipes. So if we directly connect any engine through the gear mechanism, then it may fail. So hydraulic pumps are installed here, which are slow but extremely powerful. Now, can you tell me why this string is rotating when there is no need to rotate it? There is another reason behind this. If we strike the stone at only one place, even with a normal hammer, then the chances of it breaking are less. So when the hammer rotates while striking, it will be able to cut the stone properly, and the Borewell bore will be made in a round shape. And the most important thing is that when the drill is at a great depth, the hammer can get stuck somewhere. So rotation is very important for safety. There is also a robot arm attached on the side, which automatically picks up these pipes and connects them to the swivel. Some hydraulic pumps are also attached to this robot arm. Apart from these, there are many hydraulic pumps attached. So a small engine is also installed here to operate all of them. I hope this video will get good support from your side. You can enjoy even better videos by visiting the channel. Thank you.